Okay, so in example 1.3.2, they give you 4 points. A is, McCartney, tell me what these 4 points are. A is what? One point 3.2, babe. Next page. Okay, tell me what A is. 1, 1. Okay. B.
5, 30.
C.
3, 0.
3, 0. And D.
-1 and -2.
Okay, so they're asking you to prove, prove that these points are the vertices of a parallelogram. Parallelogram, is that right? Okay. Oh, that ain't right. Maybe that's better. Okay. If it's not, y'all don't tell me. All right. So there's some words up here that you've got to understand. You've got to understand what they're asking. What are a couple of words up here that you have to understand the meaning of? Vertices. And parallelogram. Now, if you don't understand what those are, you've got the skills to do this. We did it on our summer work. But if you don't even know what this is, you cannot begin to prove it. How would you describe vertices? Okay, so we're drawing big pictures. But it's where the line would change directions, right? Where two lines come together and would almost change a direction. So like you have vertices of a triangle, right? You have a vertex of an angle. So the next thing is, so these are the points, so to speak, of a parallelogram. Well, what in the world is a parallelogram? What are some key components or characteristics of a parallelogram? All sides are, now not necessarily, of course they cannot be parallel, all 4 of them to each other, but give me an example of a parallelogram. Give me an example. A square. Another one? A rectangle. Okay, so what we know is maybe a rhombus. So y'all have not had a full geometry class, so this is a little bit somewhat foreign. Y'all may have learned it in elementary school or middle school. So what we know is that sides AB and DC are parallel, right? And AD and BC are parallel. Now, is that a parallelogram? Well, the top and the bottom are parallel. Okay, the sides aren't. So that means that these also have to be what? Not only parallel, they have to be same, equal in length, right? Because if I extend this one out a little bit longer than I extend this one out, am I going to have a parallelogram? No. Fine, following me. So, I want to challenge you to think, how can I use the skills that you'll be tested on tomorrow, quizzed on tomorrow, that you had to work on this summer to prove that A, B, C, and D are the vertices of a parallelogram? Find the distance. Because if this distance is equal to this distance, and, because these could be equal distances, right? But does that mean, like, you want these to be equal distance, but this can be equal distance, couldn't they? Doesn't mean they're parallel. But if these are equal distance, then we got a parallelogram, right? What else could we use? What is something else we could use? Slope. Because if this slope is equal to this slope, and this slope is equal to that slope, then I have a parallelogram. Can y'all do those skills? I hope so. Let me do the distance one real quick because I feel like that one needs more attention given to it. All right, hold on just a minute. Go ahead and start distance for me. You're going to have to find the distance of AB and the distance of DC and check and see if those are equal. Yes, ma'am. I do. I can send her down, yes. All right. Bye-bye. Amy, I will send you to Miss Martinell in just a minute. Okay. So AB. Now remember, distance is like Pythagorean theorem. It is Pythagorean theorem modified. So we have the square root. What's the difference in my x coordinates going from 1 to 5? What's the difference? 4. And it has to be squared. On Pythagorean theorem, it's a squared plus b squared. So what's the difference in my y coordinates? 2. So 4 squared is 16, 2 squared is 4, so AB is the square root of 20, correct? Now I'm going to check DC. Okay, the difference here, 3 to negative 1 is 4. The distance here, the distance is 2. It's in the negative direction. Does it matter whether I put 2 or negative 2? Why? I'm squaring it. But the distance is 2. 4 squared plus 2 squared, again, I get the square root of 20. Now that's great, but that doesn't prove that that's a parallelogram. Because I can have lines of equidistance, but it's not a parallelogram. Okay? So, I have to find the distance BC. So, the distance from B to C, from 5 to 3 is 2. From 3 to 0 is 3. So, that's 9 and 4 square root of 13. Does that look right? And then, so that's BC and AB. 1 to 5 is, no, AD. 1 to negative 1 is 2. 1 to negative 2 is 3. I get the same thing. And you can check slope. You would check the slope of AB. It should be equivalent to the slope of DC, which should be equivalent to, BC should be equivalent to AD. So you're going to hear me say this dozens, if not hundreds of times. You've got to learn and reinterpret the question because you have the skills. Now, turn to where it says exercise 1A. And I want you to work number 3. Exercise 1A, and I want you to work number 3. Using the same thought process that we just did here. Go ahead, Amy, and down to Miss Martell's office. So as you read that problem, what is a term that you need to be familiar with? isosceles triangle. So now, to put everybody on the same page, what are the characteristics of an isosceles triangle?
Two sides are equal.
Do what two sides are equal. Okay. Okay, so what we had to do is we have a triangle formed by the points -3, -2, 2, -7, and -2, 5. Okay, so doesn't really matter. You've got this triangle A, B, C. So you want to find the distance of the A to B. Let's call this one A, B, C. So the distance A to B, that's 5 squared, and that's another 5 So that's the square root of 50. So this I'm going to say is the square root of 50. From B to C, that's 4 squared and 12 squared. So that's the square root of 160. And then C to A, -2 to -3, there's your 5 squared. 5 to, no, wait a minute, that's 1. Wait a minute. C to A. Did I write something in wrong? Let me look at it again. -2, 5. No, okay, wait a minute. So that's 1 squared, right? Here we go. And then that's 7 squared. So that's 1 and 49. There's your square root of 50. So you've proven that that's an isosceles triangle because you found the distance of all 3 sides, and 2 of them are the same. So you kind of see where I'm going with this class, and this is what we're going to have to deal with all year. Okay, so we're going to do a couple of other things really quick. Turn to page 11. Page 11. Exercise 1B. Look at number 1. It says test whether the given point lies on the straight line or curve with the given equation. So I want you to read that, and then I want somebody to raise their hand and tell me what we would do. How would we test that? How would you determine if the point 1, 2 is on the line y equals 5x minus 3? Just substitute. Substitute. So, what is your y? 2 equals 5. What's your x? Does that point work? Yes. All right, I want you to check C and E for me. You can use your calculators. Okay, what did we come up with both of them? Yes, they should work. So look at number 1C. Your x is 3. So you got 3 squared plus your y is negative 4 squared, and that should equal 25. So 9 plus 16, 25 equals 25. Checks. All right, let's look at E. E looks a little bit scarier, but it's not really. The y is 1.5. You could also write that as 3 over 2 if you want to. That'd be fine. Then you've got your x is 1, so you've got 1 plus 2 over 3 times 1 minus 1. So you've got 3 over 2. Is that equivalent? Yes. Okay. Turn over to page 12 and look at problem number 11. Okay. Page 12, problem number 11. Page 12, number 11. Now, this says, find the points of intersections of the following pairs of straight lines. I want y'all to be thinking about how you've been taught to solve this in the past. Who can remember? How many equations do you have? Two. How many unknowns do you have? Two. 2 equations, 2 unknowns.
Is it where you put a hypothesis chart?
Like a system of equations. Okay? Like a system of equations. Now, I'm going to tell you there are various methods to solving a system of equations. The one that you're most familiar with is the elimination method. Okay? Elimination method, where I would set this up in standard form. Can I put 2y equals x minus 1 right here? What do I have to do to that? I need to have it in the same standard form. So what do I need to move? Make it negative x plus 2y equals negative 1. Well, I'm fixing to show you a really nice little thing your calculator will do for you to double check. Now, what I'm sitting here telling you is I'm going to show you how your calculator will help you, but do not do these problems without writing something down. Okay? You can check, but you need to do some type of work with this. So, I was told last period that you were not shown this before. So, I'm going to show you. If you'll look above tangent, and there's something called syssolve. So, you want to do second tangent. Let's look up there. Does everybody see system solver? And you see 2 by 2, and you see 3 by 3. Now, this means 2 equations, 2 unknowns. Okay? So if you have 2 equations and 2 unknowns, we'll pick the first one. If you have 3 equations and 3 unknowns, like x, y, and z, then you would pick the second one. So we're going to pick the first one. Okay? Now, what is the first coefficient that I need to put in? I don't have it up here. Y'all need to look at it. 3. So press 3 and then press enter. And then it asks you, do you want a plus or minus here? Okay, plus. So if that's not plus, you need to change it to plus. What's the coefficient of the y? 4. And then that's 33. Is that correct? All right, now what's the second one? Negative 1. Be sure to put a negative in there, not a minus. Is that plus or minus? It's plus, isn't it? Okay, I need to change mine. And was it just 1y? Is it 2y? All right, and what's the last number? Negative 1. and then it'll come down and it's going to highlight solve like right there, and you press enter, and so it tells you your x is 7, your y is 3. Nice handy dandy little way to do it. Now I'm fixing to show you, I'm going to go back and show you how we would do this by hand. So if we have this, we have to eliminate a variable. So if I'm going to eliminate, let me eliminate the y's. So 4y and negative 4y would eliminate, would they not? So I'm not changing anything with the first equation, nothing. What am I multiplying the second equation by to change 2 to negative 4? So that becomes 2x, and then that becomes 2. Add these up, 5x, those eliminate, x equals 7. Then I plug 7, it doesn't matter which one I plug it into. That's how you do it the long way. Okay? So I want y'all to try, let me make sure I give you the right one, C for me. So 2 equations, 2 unknowns is always going to be a system of equations. Okay, you should have the 2 answers, negative 1/4, negative 7/8. Yes or no? Okay. All right. So those are systems revisited quickly. All right. Okay, turn to what would be page 17. We're going to talk about surds and indices. Surds are like square roots, cube roots, other roots. Indices are exponents. I'm going to do a couple of really quick reviews. Actually, I'm going to be on page 18. There's a rule in the gray box. one thing that I hate about rules sometimes is we as teachers fail to show you that you need to read them backwards and forwards. Okay? So if you've got the square root of xy, it's the same thing as the square root of x times the square root of y. Or, in reverse, the square root of x times the square root of y is the square root of xy. So, if I've got the square root of 8 times the square root of 2, that gives me the square root of 16, which can be reduced to 4. Straightforward, simple. You can multiply them. Anything under the radical, you can multiply. Okay? Now, let's talk about the division. The square root of x divided by the square root of y is the same thing as the square root of x divided by y. So, for instance, if I had the square root of 25 over 36, you may not think you know what that is. But if you separated it out as the square root of 25 divided by the square root of 36, what's the square root of 25? And the square root of 36? Okay, so they can be multiplied. A whole fraction can be split apart. What they cannot do is they cannot be added unless the radicals are the same. So, I cannot add the square root of 8 plus the square root of 2. That is not equal to the square root of 10. These are not the same. It's like as if this was x and y. I cannot put them together. Okay, they're two separate things. But what I have to do is if I can simplify this to give me a square root of 2, then I can. Can square root of 8 be simplified? What is it? You do it on your calculator. 2, no, the square root of 8 is not 4. 2 square roots of 2. So square root of 8 can be simplified to 2 square roots of 2. So if I had 2x plus x, what would y'all tell me? 3x. This works similarly. 2 square roots of 2 plus 1 square root of 2 gives me 3 square roots of 2. Now, this is rinky-dinky stuff that I know you can do in your calculator, although when we get to this tomorrow, you're going to do most of it without a calculator, and it's to build your knowledge of radicals. Because you're not going to be doing this, obviously, this is too simple. But it's to build your knowledge of the rules of radicals. Okay. Let me look at something real quick. Okay. All right, I'm going to stop right there. We got that far.